Hello everyone, my name is Zhang Hanbo. Today I'm going to talk about the interactive word grounding and grasping in Clutter. Let's start with an example in our daily life.
Hi Dutch, could you please pass me the remote controller?
In this scene, the robot is expected to follow the human's verbal instruction and take the scene image as input to finish the specified task. To achieve this, there are several challenges. Firstly, the robot needs to understand the verbal concepts. Secondly, the robot is required to match the verbal instruction to the verbal concepts. And finally, due to clutter and physical constraints, the robot should understand the physical interactions and relationships among objects to avoid damages when planning grasping. Recent progress in deep learning makes it possible to accomplish this complicated task. By taking the verbal image as an input, we can apply object detection networks to detect objects. Along with verbal instruction, we can utilize verbal grounding methods for verbal linguistic matching. And to recognize physical relationships, we can use verbal relationship networks. Then what's the problem here? The answer is that the verbal models are not always reliable. There could be object detection failures, relation detection failures, language ambiguity, or the target might be occluded. Such uncertainty should be properly handled during grasping. To handle uncertainty, we integrate planning into learning. There are several ways to do so. For example, we can embed prior structure of learning into neural networks, or we can learn the dynamics or observation models to bridge the gap between the planning algorithms and complex observations and states. In our work, we follow the latter choice. In detail, we introduce POMDP on top of our learned models to take the advantages of both learning and planning. The learning makes handling high-dimensional and structured inputs possible, while planning could help to trade off between information gathering and grasping, and take use of history to alleviate uncertainty. Here is our solution. Our system takes image and verbal instruction here as an input, and during the learning part, the robot will receive perception as an observation, including target scores of objects and the relation scores of object pairs. The POMDP planning part will take the observation to update belief over the underlying state. Our belief is a graph, in which the node is the target probability of the corresponding object, and the edge gives the belief over the possible relations. If the uncertainty level is high, the robot will ask questions to get more information. We impose a question template to mean something, and the object-specific part will be generated by image captioning models. After receiving the answer, the target belief will be updated accordingly. If the uncertainty level is low, the robot will try grasping and go to the next step. We validate our proposed method in 10 clutter scenes. For each scene, we recruit 10 participants to interact with the robot. Each participant is required to describe one object freely in its name. For example, pass means broke up on top. This table shows a comparison between INVIGORATE and the one-shot baseline, benefiting from the interaction and planning. Our method outperforms the baseline significantly with p-value less than 0.01. We also conducted a series of evaluation studies. We can conclude that historic information reduces the number of questions since it will lower the uncertainty for the belief estimation, and interaction helps to reduce the failure rate with a p-value less than 0.01. Here's the demonstration showing how our system works.
Hi Dutch, could you pass me my blue notebook?
Certainly.
We can see that the robot cannot see the target directly, so it is trying to clear the table and search for it. Now it sees the target and grasps it.
This is for you.
Thanks. Hi Dutch, could you please pass me the remote controller?
Do you mean this remote controller on the right?
Yes.
There is ambiguity, so the robot will ask a human to confirm which one
This is for you.
Thank you.
More details could be found in our paper. Thank you for watching.